Could something we can't see actually control the universe? Is it true that most of the cosmos is made of stuff we can't even touch? And what would happen if this mysterious force suddenly disappeared one day? We call it dark energy. It's something we can't see or feel, yet its effect is everywhere. The story began with a strange discovery that changed our understanding of the universe forever. Let's go back to 1998. At that time, two teams of astronomers were studying the light of exploding stars called supernovae. Supernovae are massive stellar explosions, and because their brightness is measurable, they help us determine how far away galaxies are and how fast they're moving. But when scientists analyzed the data, something just didn't make sense. The universe wasn't just expanding, as it was expanding faster and faster. It was as if some invisible force was pushing everything apart. That was the moment the term dark energy entered science. But the idea itself wasn't entirely new. Decades earlier in 1917, Albert Einstein had introduced something called the cosmological constant in his theory of general relativity. Back then, most scientists believed the universe was static, neither expanding nor contracting. To keep things balanced, Einstein added a repulsive term to his equations, a kind of anti-gravity, to hold the universe in place. But when Edwin Hubble discovered in 1929 that galaxies were actually moving away from each other, proving that the universe was expanding, Einstein called his constant the biggest blunder of my life. Yet, it seems his mistake might not have been a mistake after all. Because today we need a similar force to explain why the expansion of the universe is speeding up. According to observations from missions like WMAP and Planck, about 68 to 70% of the entire universe is made up of dark energy. That means nearly 3/4 of everything that exists is something we don't understand. For comparison, all the stars, planets, gas, dust, and even us, we make up only 5% of the cosmos. The remaining 25% is dark matter, which we also can't see, but at least we know it has gravity. Dark energy, on the other hand, acts like a negative pressure, an anti-gravity force that makes space itself expand. But where does it come from? Scientists still don't know. One theory suggests that dark energy is simply the energy of empty space itself, meaning even nothing isn't truly nothing. Even in a perfect vacuum, quantum fluctuations constantly create and destroy tiny particles. This is what physicists call vacuum energy. However, when they calculated how strong this energy should be, they got a number that was 20 times larger than what observations show. Some have called it the worst prediction in the history of physics. Another idea called quintessence suggests that dark energy might not be constant at all. It could change over time, like a mysterious field spread throughout space, slowly shifting in strength as the universe evolves. Still, none of these models fully explain what's happening. Others have gone further, proposing that maybe gravity itself doesn't behave the way we think it does. Perhaps on cosmic scales, the laws of gravity are different, and what we call dark energy is just a side effect of that. But one thing is certain. Without dark energy, our universe wouldn't look like it does today. Without it, gravity would slowly pull everything back together, collapsing the universe in what's called the Big Crunch. Instead, the opposite is happening. Space is stretching, galaxies are drifting apart, and in the distant future, there might come a time when no light from the stars will be visible at all. If this acceleration continues, then in about 100 billion years, even the nearest galaxies will fade from view. The night sky will be darker than ever. Meanwhile, our modern technology is helping us chase this cosmic mystery. In 2023, the European Space Agency launched the Euclid Space Telescope, designed to map billions of galaxies in 3D and trace the influence of dark energy over time. At the same time, the Vera Rubin Observatory in Chile is scanning the southern sky, looking for subtle patterns in how galaxies cluster and drift apart. Each new piece of data brings us one step closer to understanding this invisible force. But the influence of dark energy isn't just out there in distant galaxies. It also decides the ultimate fate of space and time itself. If the strength of dark energy keeps increasing, the universe could end in a big rip. Expansion would become so extreme that first galaxies, then stars, then atoms, and finally space itself would be torn apart. If, on the other hand, dark energy weakens, the expansion could slow down and reverse, leading to a collapse once again. Either way, the fate of everything depends on something we don't yet understand. And maybe that's what keeps science alive. Curiosity about the unknown. Think about it. Here we are, on a tiny planet in an ordinary galaxy, talking about a force that shapes the entire universe. Maybe one day we'll figure out how dark energy really works. Maybe we'll even learn to harness it, an infinite source of power beyond imagination. For now, all we know is that it's there, silent, invisible, but stronger than anything we've ever known. So next time you look up at the night sky, remember that darkness isn't really empty. Somewhere out there beyond the stars, a mysterious force is pushing everything apart. And that leads to the ultimate question. Will we ever uncover where dark energy truly comes from? Or are we destined to remain forever as observers of an endless expansion? What do you think? Is dark energy an unsolvable mystery, or the key to the future of the universe? Tell us in the comments, because this story has only just begun.